now we have the ability to emit one particle when one of our particle gun paint bullets collides with something, but we don't yet have the ability to control where those particles are emitted from or anything else about it. So in order to get detailed information about our collisions, we're going to need to get a list of particle collision events. And let's just take a quick look at the docs page for that. So the particle collision event is a struct, and it contains the following variables: the collider or collider 2D for the game object struck by the particles, the intersection point of the collision in world space, or in world coordinates, the geometry normal at the intersection point of the collision, and the incident velocity at the intersection point of the collision, right? So we are going to use this heavily throughout the session to get information about where and what our particles have hit. All right, so the first thing that we're going to do, let's return to our particle launcher script. We're going to need to add a list of particle collision events so that we can store the results from on-particle collision. So on particle collision, we're going to use the particle physics extension .get collision events function, and one of the parameters for that is a list of particle collision events. So just to get ready for that, we are going to create that list now. So we are going to add a list of particle collision events called collision events, and then we're going to initialize that in start. I'm going to say collision events equals new list of collision events. Okay, so now we have our list ready to use, and we are going to now call the particle physics extensions .get collision events function, and we're going to pass in the particle system that we want to get collisions from, which in this case is the particle launcher. We're going to pass in the game object that was hit and the list of collision events. So we're going to pass in particle launcher, other, and our newly created list of collision events. And so now our list of collisions, it's going to store a set of particle collision event data, and we're going to use that in emit location. And so what we're going to do is we're going to go over the list with a for loop and then call emit location, passing in each particle collision event. So let's make our for loop. So we're going to for in I is less than collision events dot count, right? So we're going over the list. Oh, come now. Collision events dot count, and then we're going to call emit at location and pass in collision events I, right? So we're going to pass in each particle collision event, and so we need to add to emit at location a particle collision event argument, and we're going to call this particle collision event, the longest variable name ever. And so now what we want to do is in emit at location, we want to use that data. So we want to both position and rotate our splatter particle system before it emits the particles, right? So we're going to be moving around this one system, emitting particles at each of these locations before repositioning and re-rotating it and emitting again. So we are going to set the transform.position for splatter particles to equal our particle collision event dot intersection, which is going to be a position in world space. So we're going to position the system at the intersection of our collision, and then we're also going to rotate it. Now, it's worth noting in our particle collision event, that this returns a, or that this, the data here is a normal. So we're going to need to calculate the rotation that we want, right? So what we're going to do is we're going to say splatter particles dot transform dot rotation equals quaternion dot look rotation particle collision event dot normal. So in this case, we are going to have our splatter particle system rotated away from the surface that was hit before it emits. So it's going to emit in the correct direction based on the surface that was hit. So now we should be able to save our projectile launcher script, return to Unity. Now, if we play, yeah, we can see that particles are being emitted following the intersection point of our paint bullets. That green is a little light, but you can see it there. All right, terrific. So far, so good. Let me just quickly check the chat, see how everybody's doing, and then we'll continue. Somebody is asking about clearing the list of collisions. It's going to get reassigned at each collision. So no, you don't need to manage it further than just calling get collision events. Preston Woolsey, did I use a subsystem? No, I'm not using sub emitters. These are all single particle systems.